Properties of Sprite in Cocos2D. In this section, we are going to see various properties of sprites in Cocos2D application using Xcode. Let's start by creating a new Xcode project. Choose the Cocos2D template and give a name to the project. Now open the Hello World layer implementation file. In the implementation of the init method, let's remove the code section, which adds the Hello World label to the scene. In Cocos2D, if we are to add any image to the scene, then that is to be done as CCSprite object. A CCSprite object will carry an image with it. Since we are dealing with the properties of Sprite here, let's create a CCSprite object. Before giving the file name for the Sprite image, let's first add an image to the project. Since we are trying to add a background, select one background image. Now we can give the name of the image added as the file name for the background Sprite image. The positioning of a Sprite object can be done using its position property. The position property takes a point as input, i.e., a x and y coordinate of the location. The point input can be of type CCP, which is a CGPoint object or CGPoint. Let's first see how to use CCP for giving the position. Now we can build and run the application. As we can see, the application is running on the simulator. The screen is empty with only its black background. This is because we have only created the Sprite object and set its position, but we haven't added it to the scene. Any object that is created in Cocos2D project need to be added to the scene in order for that to be displayed on the screen. So now go to the implementation file and add the Sprite object created to the scene. This can be done using the addChild method of the class. Now if we run the application, we can see that the background image in the screen which we have added. Let's stop the execution of the application and go back to the code. Here let's see how to give the input to the position property of Sprite as CGPoint. We can use the CGPoint method to create a CGPoint from x and y coordinates. Let's build and run the application to see the code in action. We can see that the positioning of the Sprite object using CGPoint also is working fine. Now let's try changing the x value of the position value. If we run the application now, we can see that the background image is repositioned accordingly. Let's make the input type to CCPoint for now. Till now, we have seen how to position the CCSprite object using its position property. All these times while running the project, we have seen that the center point of the image coincides with the given position, i.e., the center of the image is placed at the position that we have given. We can change this default behavior of a CCSprite object using its anchor point property. The anchor point values will mark the point in the sprite. It can take values from 0 to 1 for both x and y values. So let's try making the anchor point of the sprite as the coordinate 0, 0. Now run the application to see the difference. As we can see, the anchor point 0, 0 made the bottom left corner of the sprite as its anchor point, and the position property set to it is applied to that location of the sprite, and the whole sprite is repositioned accordingly. We can make the center of the sprite as anchor point by giving the input to the anchor point property as 0.5, 0.5. Now if we run the application, we can see that Sprite is positioned at the center of the screen. Similarly, if we change the anchor point value to 1, 1, then the anchor point will be shifted to the top right corner of the sprite. Run the application to see the difference in action. From this, we can conclude that the position property and the anchor point property of a sprite are interlinked. It is possible to add any number of sprite objects to the Cocos2D scene. So let's create a new sprite, position it, and add it to the scene. Add a new image file to the project. Give the file name of the new image added as the file name for the new sprite. Let's remove the anchor point property for the background sprite for now, and run the application. As we can see, the new sprite is visible above the background sprite. Now let's remove the code section used for creating, and add it after adding the new sprite to the scene. Run the application to see the difference. As we can see, there is only the background sprite visible in the screen. This is because the order of the visibility of multiple sprites added to the screen is based on the order in which they are added to the scene unless specified explicitly. Here, since we have given the code to add the background sprite after adding the new sprite will be added first and the background sprite will be added next. Since the background sprite image covers the whole screen, the new sprite behind it is not visible. It is possible to specify the order of visibility of sprites while adding it to the scene. This is using the add CGPoint method of the class. Here, the parameter passed to the Z section will decide the visibility order of the item added. By default, the order of the visibility will be 1. So let's change the order of visibility of the background sprite to -1. Now run the application. We can see that the order of visibility has changed, and now the new sprite is visible above the background sprite. This is because the visibility order of the new sprite is by default 1, and that of the background sprite is explicitly set to -1, i.e., lesser the visibility order, more deeper the item will be. Next, we can see flip property of a sprite object and how to use it. There are basically two flip properties associated with a sprite object. The first one is the flip X property, which will flip the sprite horizontally if given the value of yes or true. Let's add this to the new sprite. Run the application and we can see the new sprite flipped horizontally. The second one is the flip Y property, which will flip the sprite vertically if given the value as yes or true. Let's set this property of the new sprite to yes and run the application. As we can see, the resultant sprite object is flipped vertically. Moving forward, let's remove the flip properties of the new sprite. Next, we are going to see how to scale a sprite object. There are three properties of a sprite object which enables us to scale it. They are scale, scale X, and scale Y properties. All these properties take the value from 0 to any number. The value is 1 means it's the original size of the sprite object. If the value is less than 1, then it means that the sprite object will be scaled to a smaller size. Similarly, if the value is greater than 1, it means that the sprite object will be scaled to a larger size. First, we can see the scale property. Let's add the scale property to the new sprite and give its value as 0.5. Now run the application. We can see that the new sprite is scaled to half its original size, both horizontally and vertically. Let's try changing the scale value to 1.5 and run the application. Now we can see that the new sprite is scaled to a larger size, both horizontally and vertically. Now let's change the scale value to 1 and run the application. We can see that the new sprite is scaled to its original size. Next, we can see the scale X property of a sprite object. Let's give the scale X value as 2. Run the application to see the difference. As we can see, the new sprite is scaled to double its size horizontally, but retained its size vertically. This is because the scale X property will handle only the horizontal scaling of the sprite object. Next, we can see the scale Y property of the sprite object. Let's give the scale Y value as 2. Run the application to see the difference. As we can see, the new sprite is scaled to double its size vertically, but retained its size horizontally. This is because the scale Y property will handle only the vertical scaling of the sprite object. Next, we can see how to rotate a sprite object. This can be done by using the rotation property of the sprite. The input given to this property will be the value in degree between -360 to 360 degrees. Let's give a rotation of 90 degrees for the new sprite using its rotation property. Run the application to see the code in action. We can clearly see that the sprite is rotated clockwise 90 degrees. Let's go back to the code and change the value of rotation from 90 to 180 degrees. Now run the application. As we can see, the sprite is rotated 180 degrees clockwise, so if we give the degree value as positive value, then it means clockwise rotation, and if the degree value is given as negative value, then it means anti-clockwise rotation. These are the basic properties of CC Sprite object that we will be using commonly.